Hello, today we're going to go over Newton's laws of motion. Why things move the way that they do. There is a reason. Sir Isaac Newton was an English scientist. He was born in 1642 and died in 1727. Newton is best known for three very important principles of physics called classical mechanics. These principles describe how things move and are referred to today by his name, Newton's laws of motion. The purpose today is to understand Newton's three laws of motion. We'll define forces that affect motion, and we'll experiment with the three laws of motion. Newton's first law. An object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an unbalanced force. Inertia. Another name for the first law of motion is the law of inertia. Inertia is the tendency of an object to resist changes in its state of motion. The more mass an object has, the more inertia it has. All objects have inertia. It's hard to change motion of an object with lots of inertia when something is really heavy like an elephant. It's easy to change motion of an object with little inertia, such as a penny or anything small that you could probably carry in your pocket. With no outside forces, this object will never move. With no outside forces, this object will never stop. What does this mean? Basically, an object will keep doing what it was doing unless acted on by an unbalanced force. If the object was sitting still, it will remain stationary. If it was moving at a constant velocity, it will keep moving. It takes force to change the motion of an object. If objects in motion tend to stay in motion, why don't moving objects keep moving forever? On Earth, there are two opposing forces to movement, gravity and friction. In space, there is no matter nor gravity. There's a vacuum, not the kind that you clean your house with. Gravity. If you throw a ball upwards, it will eventually slow down and fall because of the force of gravity. Friction. A book sliding across a table slows down and stops because of the force of friction. You can see there is friction on the book and friction on the table. So it would take a force for motion to occur. If the forces are not equal and opposite, then the forces are unbalanced and the motion of the object changes. Examples: a soccer ball is sitting at rest. It takes an unbalanced force of a kick to change its motion. Two teams are playing tug of war. Both teams are exerting equal force on the rope in opposite directions. This balanced force results in no change of motion. Newton's second law. Acceleration is produced when an unbalanced force acts on an object. The more mass the object has, the more net force must be used to move it. F equals ma. Acceleration is the measurement of how quickly an object is changing speed. So you have the force and the mass of the object and the acceleration. The more force, the more acceleration. But what does F equal ma mean? Force is directly proportional to mass and acceleration. F equals ma basically means that the force of an object comes from its mass and its acceleration. If you double the mass, you double the force. If you double the acceleration, you double the force. Hopefully you're following along with me okay. Imagine a ball of a certain mass moving at a certain acceleration. This ball has a certain force. Now imagine the ball is twice as big, double the mass, but keep the acceleration constant. F equals ma says that this new ball has twice the force of the first ball. Now imagine the first ball moving twice the original acceleration. F equals ma says that the ball will have twice the force of the ball at the original acceleration. Examples. If a soccer ball is kicked, which direction will the soccer ball go? Force causes acceleration of the object to accelerate in the direction of that force. Now, we've all been to the grocery store and we've all pushed carts around. It's easier to push an empty shopping cart than a full one because the full shopping cart has more mass than the empty one. This means that more force is required to push the full shopping cart. Newton's third law. For every action, there is an equal and opposite reaction that acts with the same momentum and the opposite velocity. Every action has an equal and opposite reaction. What does this mean? For every force acting on an object, there is an equal force acting in the opposite direction. Right now, gravity is pulling you down in your seat, but Newton's third law says your seat is pushing up against you with equal force. There is a balanced force acting on you. Gravity pulling down, your seat pushing up. Examples. Kicking a soccer ball has an action and reaction. The action is the person kicking the ball. The reaction would be the ball moving from the force of the kick. When air rushes out of a balloon, the opposite reaction is that the balloon flies up. When you jump off a small rowing boat into water, you will push yourself forward towards the water, and the boat goes backwards. Now that we have learned about Newton's laws of motion, it's time for experiments. Materials needed. A variety of balls, weights, and sizes of your choice. Whatever you have available would be fine. Basketball, soccer ball, volleyball, bouncy ball, tennis ball, golf ball, ping pong ball, marbles, etc. You'll need 2 medium-sized bowls, a few cups of flour, and flat surfaces. We are ready now for Newton's first law experiment, ball bounce. Materials needed are a basketball, a tennis ball, and a flat surface outside. You can use whatever 2 balls that you have available. For the ball bounce, you're going to drop a basketball and a tennis ball side by side to compare their bounces. Start them off at the same height and observe. Take a few minutes for this activity. Make a hypothesis. That's a good guess about what will happen when you stack the small ball on top of the bigger one and then drop it. Try it. It may take a couple tries to line them up just right, but the results are pretty awesome. Take time to experiment. Be patient. The energy of motion from the bigger ball is transferred into the smaller one. Most of your attention is on the skyrocketing smaller ball, but if you look at the basketball, it doesn't have much bounce at all. Now is the fun time that you get to experiment further. So take time and get a variety of balls. Think about ideas. What if you switch the 2 balls and drop the smaller one on the bottom? What if you use 2 balls of the same size? What happens to use different types of balls? So think about this. There's balls that bounce more than others. There's many sizes of balls. And of course, the textures are different. So all of that makes it fun to experiment. Take as much time as you want to try some of your ideas. It's time for the second law experiment, craters. Materials needed: 2 different size smaller balls. Example, a ping pong ball and a golf ball. 2 medium-sized bowls and 4 cups of flour. Drop both balls simultaneously from the same height and watch them fall at the same speed. Take a few minutes to practice dropping. Make sure to hold and let go. Don't add any force. Because gravity's acceleration is constant, all objects fall at the same rate, regardless of their mass. Now we're ready to have a little more fun. You're going to pour 2 cups of flour in each bowl, or the same amount of flour depending on the size of your bowls. You're going to drop one ball from a fixed height into a bowl with flour. Then you're going to drop the second ball from the same fixed height into the other bowl with flour. Take your time to get set up. Once you have completed the experiment, we'll talk about what happened. Compare the craters in the flower created by each, the impact from the two balls. Because acceleration was constant, the difference in size between the crater made by each ball illustrates that an increase in mass directly increases the force of the impact into the flower. Get creative. So here's where you get to experiment further if you want to. Think about different things. What if you use two of the same size balls dropped from different heights? What happens to use different types of balls that have the same mass? Compare the craters using different powdered substances. So you can have fun with that for a while. Now is the time to experiment with some of your ideas. The third law experiment, marbles. Materials needed, a couple marbles or any type size of balls, and you'll need a flat surface. Choose two marbles and set one marble at the end of a flat surface. Push the second marble into the first marble. Observe what happens when the two marbles collide. Notice the reaction to the collision. The action of the moving marble hitting the stationary marble caused the stationary marble to start rolling. The reaction of the moving marble hitting the stationary marble caused the moving marble to slow down. The stationary marble underwent an action getting hit and responded with a reaction slowing down the moving marble. Here's your free time to experiment. So think about different things that you can do. You can try using different sizes of balls. What happens if you use bouncy balls? What if you have a third ball? Try some of your ideas. Make observations. Well, there you have it. We've gone through all three of Newton's laws of motion. Some words to remember. Inertia, the tendency of an object to resist changes in its state of motion. Acceleration is a measurement of how quickly an object is changing speed and direction. And force is the push or pull, the strength or energy. For a review, Newton's first law says an object in motion tends to stay in motion, and an object at rest tends to stay at rest, unless acted upon by an unbalanced force. Newton's second law of motion says that force equals mass times acceleration. Newton's third law of motion says for every action there is an equal and opposite reaction. Thank you for participating with Newton's laws of motion today. If you have any questions, please feel free to contact the Rutherford County Extension Office with the information listed. I hope you've had a ball.